We're going to talk about two questions from your Semester B Quiz 1.02. Two questions that were missed most often when we look at this quiz. So this question asks, which figure or which triangle is ABC similar to and why? So you're going to see here, there's triangle ABC. Notice it has base angles of 65. Both of those are 65 degrees. The important thing to remember about similar triangles is that they have to have all angles, all corresponding angles congruent. Remember, they have the same shape, and the shape is held by the angles. So all corresponding angles have to be congruent, and then the sides have to be proportional. So we want to look at the three triangles other than ABC and see if any of these might be similar to ABC. So you'll see here, ABC has 65 and 65 as two of the angles. Now I know all angles in a triangle add up to 180. So if I want to find that third angle, I could just subtract the two angles I already know from 180 to find out what's left for angle A up at the top there. So we would take 180 minus 65 minus 65. When you do that, you get 50. So I know the top angle up at angle A is 50. And now when you look at these other triangles, you should see that there is one triangle that actually has the same angles. They're not all labeled. But if you look, DEF is not correct because you have 65 and 20. That would leave this other angle to be 95. And guys, this is just a reminder, make sure that you are not thinking about these being drawn to scale. They're not necessarily going to be drawn to scale. So look at the angle measures, not the way that the triangle actually looks. So that one's not going to work. JKL we automatically know is not going to work because it's 65 and 60 instead of 65 and 65. And so GHI we hope would work, and it does. It has 65 and 50. Just like we figured out that A was 50 up the top, G is 50 at the top of this triangle. 65 is the other base angle, which leaves 65 to be the third angle as well. So GHI is similar, and that would be by the angle-angle similarity postulate. There's one more I want to talk about from 1.02, which is this one. We're asked to solve for the value of x. Now, we can do this one of two ways. You could use similar triangles. So you could use angle-angle similarity. And with 1.02, we hadn't quite got to the side splitter theorem that we talk about in 1.03. So I want to do this using similar triangles. Although you could use it, or you could use the side splitter theorem if you have already done 1.03 when you get to this lesson. So you see those base angles to be congruent. And the reason those base angles are congruent is because these are parallel lines. Notice they're marked parallel. QC and BR are parallel lines. These angles that are marked here at B and at Q, those are corresponding angles, and they are congruent. We are talking about corresponding angles on parallel lines cut by a transversal, which is what we have here. And same with R and C. So those are congruent. Therefore, triangle DBR, this bigger triangle here, is similar to triangle QDC, or I should say DQC, by angle-angle similarity. Therefore, there should be a proportion here that is true, which is that 39, the length of DQ there, should be proportional to the side DB, the corresponding side in the larger triangle. Well, the side DB is 39 plus 26, so it's going to be 65. So 39 should be to 65. That proportion should be the same, and will be the same since these triangles are similar by angle-angle, as x, the short side here, over the long side, the corresponding long side, which is x plus 18. And so now we can cross multiply and we can solve. So we cross multiply, we end up with 65x. And then we have on the other side 39, and make sure you put parentheses when you cross multiply here. 39 times x plus 18. And we'll distribute after we get this up. We'll distribute that 39 into the parentheses. And so we'll have 65x equals 39x plus, and then we'll do 18 times 39. So you'll want to grab a calculator for this if you haven't already. 702. And we will subtract the 39x to combine like terms there. Getting those x's on the same side, getting the constant, the number without the x by itself. So we end up with 26x equals 702. We divide both sides by 26. So dividing 702 by 26, we get x equals 27. So x is 27. Again, if you've already done 1.03, you can use that side splitter theorem that we talk about on this one. But this is how to do it without that knowledge and just using angle-angle similarity. That'll be it for the 1.02 most missed questions. Thanks for watching.